everyone, welcome to InsightsByRish. In today's video, we are going to see how we can build a machine learning pipeline. Now, machine learning pipeline is actually a structured sequence of data pre-processing steps that can automate the workflow of preparing data, training the data, and even predicting the values. So let's say we have a data set, we perform imputation on that to handle the missing values, then we perform some feature scaling technique, then the dimensional reduction technique. Then if you have a categorical data, it's mandatory to convert them in numeric format, and hence we perform one hot encoding or something like that. Then we fine tune the estimator using the grid search CV. We try to achieve more accuracy by fine tuning our model, and we perform all this stuff on our data set. So if you have any data set, these are the most prominent steps that we perform on that data. So what we are going to do, we have to build such a pipeline in which we will have all these features incorporated, and so that any use case, if we have any kind of use case, any kind of data set, if we feed that data to the pipeline will automatically do all that pre-processing for us without writing the functions individually and separately. They will be all combined into that pipeline, and whenever you pass some data to that, whenever you feed a data set to that, it will perform all the pre-processing for us on our behalf and give us the output. It can do predictions, it can do evaluations and all those stuff. You don't have to do anything manually there. So let's see how we can build that. So for this video, I'm going to make use of this churn modeling CSV file. So let's start. The first thing I will write here is importing libraries. We will import all the libraries in this particular cell one by one whenever required. So first we require pandas here. Let's write import pandas as well. Then let me load the dataset here. So we just have to paste the path of CSV file here. So let me copy it. And let's display the churn df as well. So as you can see, this is the dataset that we have, in which we have both the categorical data as well as the numerical data. Now, before building the pipeline, it's also mandatory to remove the unwanted columns, because you can do all kind of data pre-processing in that particular pipeline, but you cannot remove the unwanted columns then. So it's mandatory to delete all the unwanted columns that you don't require anywhere till the end of the project. So let's say in this particular dataset, we have few columns like row number, customer ID, and surname. These are the three columns that we don't require anymore, and hence we are going to drop them. So the first thing is dropping the columns, actually unwanted columns. So here I will say churn df dot drop, and then here I have to place the names of columns that we want to drop. So the first one is row number, then the next one is customer ID, and third one is surname. And then I will also say in place is equal to true in order to make those changes permanent. Let's run that again, and let us again display the data frame here. So as you can see, now we don't have that columns anymore. We have successfully deleted them. Now these are all the important columns that we require in this project. As you can see, the first few columns starting from credit score up till estimated salary will be our input features, because that is what we are going to feed our pipeline, and this exited one will be our target variable. Now as this is a churn prediction data set, this is a binary classification one, but the pipeline can also be applied on any multi-class classification as well. So here exited basically means 0 means not exited the organization or not left the organization, and 1 means exited the organization or left the organization. Now unlike the traditional machine learning approach where we perform data cleaning, data pre-processing and all those stuff, and then we divide our data set into input features and target variable, and then we perform train test split. Here in first step itself we want to do that. So let's say dividing the data set into input features and target feature, or you can say target variable as well. So let's say starting from credit score up till the estimated salary will all be our input features, and we want to store that into a variable called as x. So this x should consist all these features except for the exited feature. So the best way and the easiest way is to drop the exited feature, and which will include all other features except for the exited. So let's say here churn data frame dot drop, and we want to drop the exited one. So basically we are doing the same thing, but in an easiest manner. We are dropping the exited column so that all other columns except for exited will be present in the input data frame. And then in our wire we will put the target feature, which is exited. So let's say churn df and here exit. So this will be our input data frame and the target data frame or the target variable. Now here we will perform train test split also. So for that we require a library here. Let me say from sklearn.model selection, we have to import the train test split module. Let's run that. And here we will perform the train test split. Let's say xtrain test ytrain and ytest. Then we will pass this train test split module here. Here we will pass our input data frame and the target feature y. Then we will give the test size, let it be 0.2, and then the random state as 42. So in the beginning or in the first step itself, when we are building a pipeline, we perform train test split, because all other things that we want to feed in our pipeline, we perform that on our input data frame and not on the entire data frame, because what all pre-processing that we require for any data set, we just require it for our input features and not for our target feature, because target feature can be categorical in nature, also it can be numeric in nature. Fine. After doing this train test split, let me also print the count here. So let me say here print, let's say count of rows in training set. So here it will be, let's say xtrain dot shape at 0, and the same thing we also want to print for the testing set as well. So the count of rows in testing set, let's say here xtest, and everything else remains same. Let's run that. So in total we had 10,000 rows in this particular data set, out of which now 8,000 rows are present in the training set and 2,000 rows are present in the testing set. After doing that, now we will start building the pipeline here. But one thing you can notice here, in this particular data set we have two types of data. One is numeric data and one is categorical data. Hence we have to build two different pipelines, one to process the categorical data and one to process the numeric data. And in the later stage we will combine both of that. So first we will build here the pipeline for numerical data. So let's say a pipeline for processing numerical data. Now in processing the numerical data, what all things we want to do? So here we want to perform imputation. If there are any missing values, that will be filled with the mean, median, mode, standard deviation of that column. Then we have to perform feature scaling, either that can be standard scaling or min max scaling. Then we also have to perform dimensionality reduction. So for that we will load the libraries first. So let me say here from sklearn.impute, we have to import the simple imputer. After the simple imputer, the next thing is feature scaling. So let's import min max scaler. You can also go ahead with standard scaler. So from sklearn.preprocessing, we have to import min max scale. And after that we also require dimension reduction technique PCA here. So from sklearn.composition, put PCA. Let's run that. So this were all the libraries for numerical processing. So let's come back to this point. Now here we will build a pipeline for numerical data. So let's say num underscore pipeline. So that's a numeric pipeline. Now for this we also require a pipeline module to be imported from Scikit-Learn. So let's say here from sklearn.pipeline, both pipeline. The module name and the library name both are same. Let's run that. Now we are going to make use of this pipeline module that we have imported here into this particular pipeline function. So let's say pipeline. Now here we have to pass all the features that we want to be processed on our numeric data. The first one is imputation. Let's name it as numeric imputation, because we are also going to perform the imputation for categorical data. Here we will pass our simple imputer. Now in the simple imputer we also have to specify the strategy that we want to go ahead with. So let's say strategy Now you can fill the missing values from your numeric data either with the mean of that column, median of that column, mode of that column, or anything. So we are going to go ahead with the mean strategy. So this was for imputation. The next thing that we want to perform on our numeric data is feature scaling. So let's say here feature scaling. In this feature scaling, we will be passing our min-max scaler. This was for feature scaling. After that, the third thing that we want to perform on our numeric data is dimensionality reduction. So let's say PCA. Now in this PCA, we want to pass one parameter, which is of n components. If you want to pass the value in the integer format, let's say we have 10 input data here, 10 features of input data here. Don't include the exited feature as that's our target variable. Just see from credit score up till estimated salary. These are 10 features in total. Let's say you want to reduce it in dimensional to some 5 features or 7 features. So you can give that value explicitly in the argument as n components. You can just say here n components and you can give that. So now your 10 features will be reduced to 7 features. But let's say I don't want to go ahead with this particular method. I just want to say that extract any 99% of important components from the entire data. So what I'm going to do here is 0. Let's say 98, not 99, 98. So what it will do, it will not extract any specific columns, but it will extract the 98% of important data that we have in this particular data set according to the importance and priority thing. It will perform all the processing in the background itself, and it will extract the 98% of the important data for us. So I am going ahead with this particular strategy. You can go ahead with the first one as well. So this was the pipeline for the numeric data. So whenever any numeric data will be passed into this particular pipeline, it will first be under the hammer of imputation, then it will go under feature scaling, and then it will be reduced in dimension. So let's also display our numeric pipeline here. Let's say numeric pipeline. So this, as you can see, this is the pipeline method that we have implemented for the numeric data. You can even maximize it. As you can see, this all things that we have in this particular pipeline. So this was the pipeline for numeric data. Now we have to build a similar pipeline for categorical data as well. So let's say here pipeline for processing categorical data. So let's name this pipeline as categorical pipeline. Categorical pipeline. Again, we will make use of that pipeline module that we have loaded. Now here we have to pass the techniques that will be used for preprocessing of categorical data. The first one will be categorical imputation. Now unlike the numeric imputation where you fill the missing values with the mathematical statistic values of that column, like mean of that column, code of that column, and all those stuff, when you are filling the missing values in any categorical column, in that case you want to fill it with some constant value, let's say missing or unknown or something like that. So let us name it as categorical imputation. And here we will pass the simple imputer function again. Let's say simple imputer module. And first we have to specify what value we are going to fill it with. So let's say fill value. In this fill value, you can fill with any constant value. Let's say you are going to fill the missing value with the word missing, or with the word unknown, or with the word none, or anything like that. So let us keep the constant word as missing. And then you also have to specify the strategy. So let's say strategy. And the strategy is constant, because as we are replacing the missing values with this constant term missing, hence we want to specify the strategy as constant. So this was the first thing, categorical imputation. The next thing will be one-hot encoding. It's also mandatory to convert the categorical data into the numeric one, for which we perform one-hot encoding. So let's say next is one-hot encoding, and we require the library for the same. So let me import it. Let me say from sklearn dot preprocessing will import one-hot encoder. Let's run that. So here we will call that module. So let's say one-hot encoder. And in this one-hot encoder, you want to pass two arguments. First one is sparse, that is sparse is equal to false. means the data won't be in a sparse format, and then handle unknown is equal to ignore. So if if the module encounter any unknown category, it will basically ignore. So handle unknown equal to ignore. So this was the second thing. So these are the two techniques that we are going to perform on our categorical data. So as you can see, these are two distinct pipelines. First one is numeric one and the second one is categorical one. Let me also display this one. So let me also maximize this. So these are the two distinct pipelines, one for processing numeric data and the second for processing categorical data. Now the next task is to combine both of them, because in our data set we will have both the kind of data combined. We can have the categorical data also and we can have the numeric data also. So numeric data, it's not necessary that it can be only integer or it can be only float. It can have any data type that belongs to a numeric nature. It can be integer, it can be float, it can be long, short, double, anything, but it should be numeric in nature. So now we come to the step of combining the two pipelines into a major pipeline. But before that, we also have to create two distinct lists. In the first list, we will keep the column names of all the numeric columns, and in the second list, we will keep the column names of all the categorical columns. Now let's build the list. So first one will be numeric columns. In this list, we will have the names of all the numeric columns. Now, whenever we are combining the both pipelines, the categorical and numeric pipeline, when we are basically combining them, at that time we also have to specify the list or the names of columns that belong to that particular category. Like along with the numeric pipeline, you also have to specify the names of numeric columns. Along with the categorical pipeline, you also have to specify the names of categorical columns. So if you specify that explicitly, like age, gender, all those stuff, then for every data set you have to keep on changing that. So it's better to create a list that will automatically extract the column names for the particular data type, and that will pass it to the pipeline. The first one is numeric column. So let's say churn df, which is our df data frame name, and then here we will make use of select data types method. So select types. Here we want to include all the columns of numeric nature. So let's say include np.number. Now this np is actually numpy, so let me also import it. Put by as n. Let's run that. And then we have to extract the columns, and we have to put that into a list. So to list function. So here what we are doing is we are extracting the column names of all the columns which are numeric in nature, and we are putting all that names into a list. This is our numeric columns list. Second list will be categorical columns list. So let's say categorical columns, and again we will say the same thing, churn df.select data types, and here we will include the object data types. All the categorical data in the data set is always present in the form of or the data type of object, and hence we are including the object data type. Let me say here columns to list. Fine. So we built this two lists. Let's run that. And it's also mandatory to confirm that we don't have any other data type in our data frame except for this two. So let's say here churn df dot info. So as you can see, in this entire data set, we either have the integer, object, float, and all this stuff. So either the data is numeric or the object. In very rare cases, it happens that the data type of the categorical column is actually category. In that case, you have to convert that data type explicitly from category to object, and then you have to build this. So we are good to go as we have all the data type in the specified format and appropriate format. The next thing here is to combine the both pipelines. So for that, we require a column transformer. So let me go here and import the library for the same. So let me say from sklearn.compose, and from this I will import the column transformer. Done that. Now this column transformer will help us to combine both the pipelines here. So let me say preprocessor. This preprocessor is a variable in which we are combining both the pipelines and we are storing it. So let's call the module column transformer. Now here we will pass our both the pipelines. So first we will pass our categorical pipeline. So let's say categorical. and here we'll pass our categorical pipeline. So the name of our categorical pipeline is, copy that. Now along with this categorical pipeline, we have to specify the column names that belongs to categorical nature. So here we'll pass our categorical columns list. See, if you are building the pipeline for a specific data set, let's consider this particular data set, then what you can do, you can basically pass the column names that have categorical data explicitly. You can just say something like this: city, or gender, or let's say something like country. But what will happen if you want to apply the same pipeline for other data sets as well? Then you have to continuously keep on changing this column names, because it's not mandatory that every data set will have all these columns. In that particular data set, we might have different categorical columns. So it's better to, instead of giving this explicitly, you can just pass the categorical columns here. Let's say categorical columns. Next, we will pass our numeric pipeline. Let's say numerical. Here we will pass our numeric pipeline, and I think the name for that is some underscore pipeline. Along with this pipeline, we also have to specify the numeric columns. So let's say numeric columns. So this was the preprocessor column transformer for combining both the pipelines. Now we have to actually build our major pipeline here. So let's say pipe, and we'll call that pipeline method. In this, we want to pass our preprocessor. This preprocessor consists of combined pipelines. This is what we have to pass in this major pipeline method. And then one thing you should keep in mind, that this preprocessor should exactly match with the name that you have given here. If you have loaded a column transformer in something different, like the name is different for that column transformer, then you should change that accordingly, because this name should exactly match with this particular name. Fine. After that, here we will call our estimator. The estimator is basically the algorithm that we are trying to apply. So as this is a classification project, we are going to apply any classification algorithm. So let's say I want to apply random forest classifier, because as I am also going to show you the fine tuning, hence I will go ahead with the random forest classifier. So let me import that here from sklearn .ensemble. We have to import the random forest classifier. Done that. So let's specify our estimator here. Random forest classifier. So this is the pipeline in which we are passing our processor, which basically consists of the combined pipelines for processing the numerical and categorical data, and the classifier. If you are building a regression model, then you just have to change the classifier object to any regressor algorithm, and after that we will fit it. So in the traditional machine learning model, what you do, you build a model. In that model variable, you call the algorithm, and then you say model.fit. So here we have to say pipe.fit, because this is a variable in which we have our processor and our estimator, hence pipe.fit. And then we have to pass our training data here, so xtrain and ytrain. Let's run that. Okay, so this issue basically you are facing it because while building this numerical and categorical columns, you have specified the data frame name as the original data frame name, but here you have to just say X, because we are extracting the column names from the input data frame and not from the original data frame. So that was the changes. Let me again run this all. Fine. So as you can see, the pipeline has been fitted, and this is the graphics that you can see on your screen. So you have the pipeline in which you have two processing units. First is for categorical and second is for numerical. In categorical part, you have just the two techniques: simple imputer for the constant one and the one hot encoder. Then in the numerical portion, you have the simple imputer with the mean, then the min-max scaler, and then the principal component analysis. And at the end, you have the estimator, which is a classifying algorithm of random forest classifier. Here we haven't specified any hypertuning parameters. Here we haven't specified any hyperparameters. Fine. So this was the pipe. Now you can even make predictions using this pipe. You can just say something like this: pipe dot predict, and here you can pass your X test. So this pipe method will also predict for you. As you can even check for the accuracy. You can even say something like this from. You can even check the accuracy here. So let's say pipe dot score. Let us pass X test and Y test. So as you can see, it's even evaluating the model for you on your behalf. So the model is having 86% accuracy. So as you can see, the pipeline can pre-process all the data for you. You didn't write any code explicitly for any kind of technique, any kind of imputation, any kind of one-hot encoding and all those stuff. The model did all the things, the pipeline did all the things for you on your behalf. Now this was the one use case. You can pass any dataset to this pipeline. You can store this pipeline model and you can pass any dataset to this particular pipeline. It will do all the pre-processing for you and will give you the output. Now let's try fine-tuning it. We have a technique called as grid search CV, with the help of which we fine-tune the hyperparameters. Now as you can see, this particular estimator, random forest classifier, we haven't specified any hyperparameters here. So we'll try hyperparameter tuning as well with the help of pipeline only. So let's say here hyperparameter tuning. So before doing that, we have to check what all hyperparameters we have in our random forest classifier. If you want to check the names of all the hyperparameters present in the random forest classifier, you just have to do one thing. You can put a question mark here and then say random forest classifier, the name of algorithm, and run that. As you can see, you will get all the documentation for random forest classifier here in Google Colab. So you can see these are all the parameters that you have. So n estimators, then the criterion, then the max depth and all those stuff. So we want to perform hyperparameter tuning here. So first we'll specify the hyperparameters along with the parametric values that we want to evaluate upon. So let's say parameters. Now while building these parameters, this will be a kind of dictionary here. So as you can see, we have put the curly braces here. So first is, now while specifying the hyperparameters here, you have to follow one format. The format is, first you have to specify the name of estimator, name of algorithm that you have specified while building the pipeline. Let's say while building this particular pipeline, the major pipeline, you have named this random forest classifier algorithm as estimator. This is the name of your algorithm that you have mentioned in your pipeline. So you have to copy that name, you have to place it here, then you have to put 2 underscores. So 2 underscores, and after that you have to provide the name of hyperparameter. So let's say the hyperparameter is estimate. Let me copy it from here and paste it here. So as you can see, this is the format that you have to follow. First will be the name of algorithm that you have mentioned while building the pipeline, then double underscore, and then the name of your hyperparameter. And then you will create a list of the parameters that you want to evaluate a model upon. So the default value of n estimators is 100. Let's say the default value 100, then the value 150 and 200. So these are all the hyperparametric values that we are giving to decide which one is the best. Then the next hyperparameter we have, again we have to say estimator, double underscore, and then we have to specify the name of hyperparameter. So let's say the next hyperparameter that we are going to specify is this. Copy it from here. Now the max depth value, the depth of the tree that we are building, the maximum depth by default, it's not given anything here. So let's say the default will give some value as 5, 7, 10 and 50. Now the third hyperparameter, again estimator, same thing, double underscore, and the name of hyperparameter, which is mean sample split. Now by default, any node is splitted into child nodes. Like a parent node is splitted into 2 child nodes. If you want to change that value, you can change that here. We'll also give the default value, which is 2, then 3, and then 4. And let's put one more hyperparameter here. And the hyperparameter here will be maximum feature. It will be somewhere here. Scroll it down. This is the maximum features. This is the hyperparameter next that we are going to specify. Now by default, the value of maximum is a square root, which means let's consider that we have 10 input features. So it will take the root of that, and that will be the maximum features considered by building every tree. The other parameters are log2 and none. but we won't give something like this. We will give the data in numeric format. Let's say the maximum features out of 10 we want to consider 2, then 4, then 6, 8 and 10. So these are all the hyperparameters that we are going to evaluate our model upon. There are many more hyperparameters present here. You can even give that, but for now I will keep the hyperparameters list to this much itself. So this was the parameters. Now we'll perform grid search CV here to evaluate that our model is performing well with which values. So for that we require grid search CV. Let me import that. Let me say here from sklearn dot model selection. Here I will import grid search CV. Run that. Fine. Let's go back to that, and here I will say this particular cell itself. I will say grid search. This is just a variable name. You can name it anything. In this, I will load that module that we have imported right now. This grid search CV. And in this grid search CV, first we'll pass our pipe. Now, pipe is a variable in which we have built our major pipeline with the preprocessor and the estimator. This pipe is what we'll pass as the first argument in this grid search CV. The next thing will be the list of parameters. So the parameter grid is one of the arguments from the grid search CV. This will be our parameters that we have built. Here. And then n jobs is equal to 1. This is just for parallel processing. And then we have to even fit that on our training set to check for the best values. Let's say grid search dot fit, and here we'll pass our training list, x train and y train. Now before running this, it will be very heavy for the system to perform all this pre-processing. Hence, let me change my runtime type for GPU. And after connecting to for GPU, we have to run all these cells again from beginning. So let me say here runtime, and if you are getting a lot of warnings like this and if you want to ignore that, one thing you can do, just stop this execution for a minute, and before this you can say something like this. Let me say import warnings, and then warnings dot filter warnings. You can just say ignore. Let's run this cell. Now if you run this, you won't get any warnings. As you can see, the execution has begun without any warning. So as you can see, after running the grid search, now you have this grid search fitted, where it shows you the grid search CV. After that, it also shows you the estimator. It shows you all the parameters on which you have evaluated your model upon. Now, if you want to check what are the best parameters for your model to achieve best accuracy, you can make use of best parameters method here. So let me just comment it out for a minute. After that, here I can say grid search dot best parameters. Let's run that. So whatever hyperparameters you have specified here, it will show you the best hyperparameter value actually among that. So for the maximum depth, the best value is 50. Maximum features, the best value is 6, and for the n estimators, the best value is 100. So it will show you the best parameters for every category or every hyperparameter that you have specified in your parameters grid. Now what we will do, we will again copy the pipe that we built initially, this pipe. So let me copy it from here. And in this particular pipe, now we will put the hyperparametric values in this particular estimate. So we will start with an estimator. Let's say an estimator value. We'll try to train our estimator now with the best parameters that we have achieved using the grid search CV hyperparameter tuning technique. The n estimator is 100, which is the default one. After that, the next is maximum features. So maximum features. The maximum features value is 6. That is, every decision tree in the random forest classifier will consider 6 features out of 10. Then maximum depth. The maximum depth is 15. And the last one is minimum sample split. So min samples split. So by default, the minimum sample split is 2, which means a parent node is always divided into 2 children nodes. But here it's saying that the minimum sample split of 3 will give us the best accuracy, and hence we'll go ahead with that. Fine. So as you can see, we are training our hyperparameters, we are fine tuning our parameters here in the pipeline itself. This is how you can do that, and then let us again run the same thing. Let me name it as pipe 2. Let's run that. So actually we missed a S here, and estimators. So this is our pipeline a second now after fine tuning, and everything else remains same. The difference is that initially we didn't mention any hyperparameters, and here we mentioned some. So this is how you can also perform grid search CV, that is the hyperparameter tuning, using the pipeline that you have built. Fine. And even now you can use this pipe 2 for prediction, for accuracy and all those stuff. So this is how you can build a machine learning pipeline that can be used for any dataset, for any pre-processing that you want to perform. Now I have also written an article on Medium about the same, that building the machine learning pipeline. As you can see here, everything that I explained in the video is also mentioned here. I have included very basic theoretical concepts here. Except for that, I have only included the implementation portions. So I will also provide the link of this article in the description box. If you want, you can check that out as well. So coming back to the code, as you can see, we implemented a machine learning pipeline. Now you can pass any dataset to this pipeline and it will work perfectly well. You can pass any use case, any dataset. Just keep one thing in mind. Don't forget to remove the unwanted columns first. Once you remove the unwanted columns, you can pass all the dataset as it is to your pipeline and it will work perfectly fine. So that's it for the video. Thanks for watching.